Hi guys, welcome back to remote learning day, what is this? Day 3? I think I'm already losing count. More new material today. We're still in the circles chapter, but we're talking about equations of circles this time. In case anybody is wondering, this is some of the stuff that comes from section 10.8. That is what we are talking about today. So I think everybody's seeing the word equation, and I hope not freaking out too much. I mean, there's a little bit of like equation stuff from Algebra 1, but honestly not too much, because the format that we use for equations of circles is pretty much completely different from anything that you saw in Algebra 1 regarding slope-intercept or anything like that. Because this is what we use most of the time when we talk about the equation of a circle in standard form. All right? It looks like this. Standard form of the equation of a circle with center at h, comma, k, and radius r is x minus h squared plus y minus k squared equals r squared. So, again, well, sort of like, actually, rewind a second. Sort of like when you guys were doing slope-intercept form in algebra. If you guys remember slope-intercept form, that was y equals mx plus b, where the m and the b were numbers. Remember, m is the slope, b is the y-intercept. And you still had your equation in terms of both y and x. So it's a similar sort of idea here. You're still going to have your equation in terms of x and y. And then h, k, and r are just numbers. All right? H, comma, k is your center, and r is your radius. So one of the things you're going to hear me say a lot throughout this video, and if I do any other Google Meet sessions, is the two things that you need to write the equation of a circle in standard form are the center and the radius. And the different kinds of problems that we're going to be talking about today are just a matter of what kind of work that you would need to do in order to get those two pieces of information. Because this example 1 is the easiest type of question that you're going to see. Write the equation of a circle with that center and that radius. So if we're using standard form, all you would have to do is plug all of the information in, all right? X minus h, which is the x value of your center. So this is h, this is k, and this is r. So x minus 3 squared plus y minus negative 3. So we can do plus 3 because minus negative is plus. Squared is equal to 6 squared. And honestly, the only other thing that you would have to do for this problem is just square 6. You can leave the left side like this, because as you saw before, that's what standard form looks like. It leaves these parentheses, these binomial squared. You do not have to FOIL this out. You should not FOIL it out, because then it's not going to be in standard form anymore. We're going to leave it x minus 3 squared plus y plus 3 squared is equal to 36. And that's standard form of the equation of this circle. All right? That's as easy as it's going to get. So example 2 is obviously going to look a little bit different. I still honestly don't think, given a graph, it's not that much harder. It's just a matter of picking out all the pieces of information. Like, you have, honestly, your radius highlighted for you. You have that your radius is 2. So this is your r. And this is your center. And it's just a matter of what point the center is at. So that's 1, 1, 2, 3. So your h, comma, k is 1, comma, 3. And you know your radius is 2. So it's all of that you're going to plug into standard form. X minus 1 squared plus y minus 3 squared is equal to r squared, 2 squared, which is 4. Make it a little easier for you. There you go. All right. The only time when this honestly might get a little bit complicated is if you didn't have all that information spelled out for you. What if you just had a circle, right? Well, the center is going to be in the middle. So the way I think about stuff like this is like, okay, I'm going to kind of split my circle up into like two different kinds of halves, right? Because the center, right, if I, this isn't making any sense, I don't think. But this and this are my high and low point of the circle. So this is like the center vertically. So I'm going to mark that off. And then the far out points, like the furthest left and the furthest right, are here and here. So this would split up my circle that way. So your center is going to be where they meet, which is right here. And that point is -1, -2. That's your center. And then in terms of your radius, well, we say the radius is just the distance from the center to any point anywhere on the outside of the circle. So we have these nice points that we made our lines through that you can just count vertically or horizontally from your center. So that's 1, 2, 3, 4. Your radius is 4. And those are all the numbers that you're going to plug into standard form. So x minus -1, so it's +1 squared, plus y minus -2, so it's +2 squared, is equal to 4 squared, which is 16. And that's that for that. All right. Things are about to get, I don't want to say very complicated, but, you know, slightly more complicated. This is geometry level 1 after all. Write the equation of the circle that has its center at -3, -2, and passes through 1, -2. So, hold on, I got to think about this for a second. So you have half of your information, at least. You have your h, k center point, all right? This that passes through this point, what that means is that this 1, -2 is a point on the circle, all right? So if we kind of, if we sort of drew this, right? Here's your center, and 1, -2 would be somewhere over here. So I said earlier that the two things we need in order to write the equation of a circle in standard form are your center and your radius. So we have one of those things. But in order to find the other, from the center to any point on the end of the circle, that's your radius. So if we're able to find how far it is from the center to this point on the circle, that's going to get us our radius. And how are we going to do that? Distance formula. A lot of people have been talking about distance formula for some reason for a really long time, and now is finally when we're going to get a chance to use it again. So again, in case you forgot, distance formula is giant square root x2 minus x1 squared plus y2 minus y1 squared. So these are the 2 points that we're going to use. 1 plus 3 squared plus -2 plus 2 squared. So this is 4 squared, which is 16, plus 0. So square root of 16 is 4. And that's your radius. So now you have both pieces of information, your center and your radius. And now we have enough to plug into standard form. X plus 3 squared plus y plus 2 squared is equal to, again, you have to square the radius. Please don't forget to do that. Or you have to square this value. 4 squared is what's going to go here. So it's 16. And there you go. We'll do one more. Again, you have one piece of information that you're going to need, h, k. That's your center. And if it passes through this point, the radius is going to be the distance from the center to that point on the circle. So using the distance formula between these 2 points. Square root of 5 minus... No. Oh, I'm forgetting distance formula. 5 minus 10. Yep. Yeah. Okay. So this is negative 5 squared is 25, plus this is negative 4 squared is 16. So that's going to get us the square root of 41 as your radius. And 41 does not simplify. You can't simplify that radical, but honestly, you don't even really have to, because if you guys remember back what standard form actually is, x minus h squared plus y minus k squared equals r squared, you're just going to wind up squaring this r value anyway. So when you plug it back in, you're going to do the square root of 41 squared, and the square root and the square are going to end up canceling out anyway. So here's what I mean by that. You have your h and your k. So this is going to be x minus 10 squared plus y minus 8 squared. And then to simplify r squared, it's a square root of 41 squared. And this cancels out. So the fully simplified form of this is all this is 41. And that's standard form of this equation of a circle. All right. So, I think I want to skip on this because there's a couple other things that I want to get to. I am going to do this later, and I will post a digital copy of this online as I have been doing. So you will see the worked out solution to this. One thing I do want to say though, if you do want to try this on your own, is you do have to be careful because the point that it passes through comes first and then your center point. So this is going to be your center. Like, you're still going to do the distance formula because it's the exact same kind of question. But this is going to be the point that you would use for h comma k. All right, just be careful of that. This one is a little different because now you have diameter endpoints. So what do we remember about diameter? Well, you know, it's got endpoints on the edge of the circle, all right? But another thing about diameter is that the diameter itself passes through the center, all right? And since we're talking about a center, that's kind of like in the middle, right? If you have endpoints of a diameter, when you're writing standard form of the equation of a circle, you still need two things, center and radius. And we don't have any of those things given to us. So this was even more work than last time. But as I was saying, and I kind of got ahead of myself a little bit, if you have a diameter and you know a diameter passes through the center, and the center is sort of like in the middle, the center is going to be in the middle of these 2 points. So how do we find the point that's in the middle? Midpoint formula. If you don't remember midpoint formula, x1 plus x2 over 2 and y1 plus y2 over 2. That's midpoint formula. So 18 plus 8 over 2 and negative 3 minus 11 over 2. So this is 26 over 2, that's 13, comma, negative 14 divided by 2 is negative 7. That's your center. That's your h and your k. All right? So, again, hold on, let me get my thoughts together. You have your center. We still need the radius though. And similar to last time, the distance from the center to any point on the edge of the circle is going to be your radius. So now you have 2 points that are on the edge of the circle. So if you know your center, you can find the distance between this point and any one of these 2 points. And you should get the exact same thing regardless of which point you pick. All right? I personally don't want to deal with that 18 for some reason, so I'm going to pick this one. You guys have the freedom of choice. If you did pick this 18 comma negative 3, you should get the exact same radius that I do. So we're going to do distance. We're going to do distance formula again. I talk too fast sometimes. So 8 minus 13 squared plus negative 11 minus negative 7, so plus 7 squared. This is negative 5 squared, which is 25. And then negative 4 squared is 16. So we get the exact same square root of 41 as our radius that we did in the last problem that we did all together. So We leave it as the square root of 41. This is your center. This is your radius. And we're going to plug all of this into standard form. So x minus 13 squared plus y minus -7 plus 7 squared is equal to, again, square root of 41 squared. The square root and the square are going to cancel out. So you're just left with 41. And that's the answer. Okay? I think there's one more like this. Yes. I'm going to do it. You need the center and the radius. If you have endpoints and the center is in the middle, we're going to do midpoint. So negative 15 minus 3 over 2, comma 7 plus 9 over 2. Negative 18 over 2 is negative 9. 16 over 2 is 8. So that's your center. That's your h comma k. And again, this distance from the center to either one of these two endpoints or points on the circle is going to be your radius. So we're going to use this and either one of these 2 points in distance formula. I'm going to go with this one again because I think the numbers are a little bit easier to work with. Negative 3 plus 9. And then 9 minus 8. Okay. 6 squared is 36 plus 1. So this is square root of 37. Not a perfect square again. Not a big deal. This is your radius, and we're going to leave it as a square root because once again, when you plug it in a standard form, square root and squaring cancels itself out. So this is x plus 9 squared minus y minus 8 squared is equal to 37. And I said this last time, or in my last video, if you think I'm messing up on something, you've absolutely every right to call me out on it and fix my mistake. But I hope it's going well so far. All right. Again, feel free to use Hangouts if you have a question. The question forum if you have a question. We can do another Google Meet. I did a Google Meet today on March 18th, and I think it went really well. There weren't that many people there. I think there were maybe like 15 people between the 71 people I have across all 3 geometry classes. So again, more than welcome to stop by if we ever do another meet. I'll probably do another one considering I'm going to be out for a while. Anyway, I'm rambling now. Couple more, and then we're done. So, I am going to have to do a little bit of doodling for this one. Write the equation of the circle with center 7, 1 and tangent to the x-axis. So the good news is that we already have one piece of information. We have our center. But I want to draw this really quick just so you kind of make sense of what's going on. So 7, 1. That's the center of our circle. All right. And what does it mean to be tangent to something again? Well, in terms of circles, when you have something that's tangent to a circle, it touches the edge of the circle at exactly 1 point. So if the circle is tangent to the x-axis, which is here, it touches the x-axis at exactly 1 point. So that 1 point is just going to be kind of like the edge. So like if I drew my circle this way, again, we're going to pretend that's a perfect circle. It's obviously not. This isn't art class. But that's kind of what we've got going on here. All right. It touches the x-axis at exactly 1 place. So now that we have sort of a visual representation of what's going on, we can figure this out because we can just count vertically or horizontally what the distance is to the edge. And since we know that like this is the point that it touches, the distance from here to here is just 1. So your radius is going to be 1. All right. And now we can plug all of that into standard form. X minus 7 squared plus y minus 1 squared is equal to 1 squared, which is just 1. That's that problem. Okay? One more, and it's pretty much exactly the same thing, just the other axis. But I am going to draw it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's your center. And if it's tangent to the y-axis, that's here this time. So here's the point where it touches, and there's your circle, sort of. So we know this, the point is, we know the point is that we know that this is the point where the circle touches the axis. So we know this is the point that we want to find the distance between that point and the center. But again, because you have a visual representation and you can go horizontally, you don't need to do a crazy distance formula. You can just count 1, 2, 3, 4. So your radius is going to be 4. So x minus 4 squared plus y plus 6 squared is equal to 4 squared, which is 16. And one thing I do want to mention about these two problems before we wrap up is there is sort of a pattern. All right. If you guys notice between the two, this one was tangent to the x-axis. And the radius, the length of the radius, corresponded to the y value. In this problem, it was tangent to the y-axis, and the radius corresponded to the x value. And that pattern, the more kinds of problems that you do like this, you're going to see that pattern, where tangent to the x-axis, the radius is the y value, y-axis, the radius is the x value. You would obviously have to be careful if you had negatives, because when we talk about radius, we talk about, that's a length of a segment, right? So if you had if this said x-axis instead, right? The pattern would be, okay, tangent to the x-axis, I'm going to look at the y value. But radius of -6 makes absolutely no sense because negative side length makes absolutely no sense. So you just want to make sure it's sort of like an absolute value type thing because absolute value always has to be positive. So if this said tangent to the x-axis and you were looking at this y value, the radius would then just be 6 instead of -6. All right. But that's all I got for you today in terms of new stuff. As I said, feel free to ask questions on anything that you are concerned about. I'm thinking this time, and I'm going to post this in the, on Classroom as well and in the assignment space. I'm thinking this time your homework might be a Google form. So in terms of homework, if it does wind up being a Google form, all you would have to do is just fill out the Google form and submit it. It would be problems that you would have to do based on all of this. But you just have to fill it out and submit it. I wouldn't be looking for an attachment of work. You wouldn't have to submit anything on Google Classroom itself because then I would have a record of you submitting the form. And yeah, so if it does end up being a form, that's how it's going to work. If it doesn't, and I give you another worksheet or book problems, I think you guys are sort of handling it well in terms of how to submit it. Book problems, you can just do on a doc and then submit it on Classroom or PDF. I don't know if you can, if I made everybody a copy of the PDF, I don't know if you'd be able to write on it. So that's the main reason why I didn't give everybody their own copy of the PDF for the assignment on the 18th. But yeah, the one thing I am going to say, and I'll probably say this again the next time there is an assignment like that, is that you do actually have to hit submit, just so I can have a record of who's actually doing their work. Even if you just do attach a picture or attach a document, you still do have to submit. You still do have to hit submit on the Google Classroom post. Okay? But yeah, I think you guys are getting the hang of it so far. As I keep saying, it's a one day at a time kind of thing. We just kind of got to manage the best we can, but you guys are doing a really awesome job so far, and I give you a lot of credit for taking all this in stride. All right. we're almost at 25 minutes, so I think I'm going to wrap up here. Talk to you guys soon.